So yeah, welcome back to your last session, 8th session of Introduction to Java. Uh, Today we'll be going over some more inheritance and more OOP concepts, object-oriented programming, and yeah, just an interesting way to finish this course off. So, yes, because to be honest, a lot of the topics that we've covered, basically every introduction topic, the things we're getting into right now are kind of complex, and it's going to be even harder to like keep up, or I guess like understand it without having a lot of practice on your own. So okay, so before anything else though, oh, my bad. Any plans for the summer? Especially because summer's coming up. Today's the last session. Does anyone have any plans? Wow, still under lockdown. Dang, that kind of sucks. But yeah, sit around all day. Well, ideally, you should try to find something productive, or maybe not even productive, fun things to spend your time on. Maybe watch a few movies. Don't just sit there. I used to sit there a lot when I was younger. So definitely don't just sit there. Okay, wait, give me a sec. Close out a PowerPoint by accident. Okay. So yeah, that's good. Try to find something to do. Well, if you can't play games or watch movies, you could always try to practice coding, read the news, do something worthwhile. So yeah. Okay. Well, before we actually get started with any more like OOP concepts, because those are pretty complex, we should definitely do some review of the stuff that we've actually learned so far. So classes versus objects. Does anybody know the difference between these? Anybody have an idea? They are indeed things. That's actually not a bad description of them, because classes and objects, objects are basically just things. So you're actually correct. And classes, well, classes are the templates that you make objects out of, right? So classes are templates from which you create objects, and then classes define these default values, what the validator values are, and what possible behaviors that the object might have. And also objects are instances, quote unquote instances. That's the term of classes. So that means that to get an object, you need to create one of a class. And like the analogy that we used last time was that if I had a cup, then you would have to the class for this cup would probably be a blueprint or some kind of mode. And then using that, you can create an object of it. So this is an object of a cup. It's an instance of a cup. So yeah, classes and objects are things. A cup is safe. Yes. Okay. Unless you break it, that could be a behavior of the class. Okay. So some of the review. How would you actually create a class? Does anybody have any ideas? I mean, if you're talking about a coding class, then yeah, maybe. Yes, that's. I guess you could create a class that's a computer science class, but when you're actually coding to use the word to create a class, you have to use the keyword class and also give the class a name, and then you define fields for the data and the behaviors of the class. You define that inside of the class itself. And here's before the example actually. Does anybody remember how to create an object? Objects, syntax, specific syntax. Actually, a good guess, but to create an object, basically all you need to do is state the class that you want the object to be of, and then you just create an instance of that class. So essentially, here's what it looks like. You have your class called student, and then you have your class called test, in which you have the main method. Don't forget, the main method is just where the code's actually executing. So essentially, you have your class code student, it gets created up here, and then your main method says, oh, let me make a new student object. And that's what this is doing. Student, myself, that's the name of the object, and then it's new student, and that's how you create a new object from this class. And obviously, this is an object of the class student. So just keep that in mind. Okay, moving on. So how would you create a string field called species inside of the class? So how would you add like a variable, a field to it? Remember, field is just what we call variables that are inside of a class. So any ideas? If not, that's fine. Essentially, you just do it like this. So you just need to put it inside of the class. You have your type string, you have your name of the variable species, and then you set it equal to here, it's an empty string, so empty brackets. And then you have your method called print species, which essentially just prints out the species of this. So that's how you do a method. You just define the method inside of the class, and then you can call it from outside of it. Or if the main method is inside of this class, you can call it from inside this class too. But here you go. That's your variables, your fields. Okay. So does anybody know what this piece of code called? This specifically, public animal, and then inside you have parentheses. Essentially, it's just a constructor. And also, before I do anything else, let me just save this because I realize I haven't saved it yet. So so this is just called a constructor. And then does anybody know why this dot is needed? So it's this dot species equals the species. Are there any ideas for why we need to have that? Separate's actually not a bad idea because you do have to separate what the computer thinks is species from the field of the class itself, which is also called species. So whenever you have a constructor, which, oh yeah, I forgot to explain constructor, but whenever you have a constructor, essentially, if you're passing in something that's got the same name as your field, as this attribute of the class, then you need to say this dot name is equal to the name of the variable, because what you're doing here is you're essentially having two variables of the same name in like one piece in one function, and your computer is going to get very confused about what's getting assigned to what if you don't use this dot species. So yeah, separate's actually not a bad idea. And also constructors. So going back to the last question, constructors are basically how you create the class. So when from earlier, if you look from earlier, we have here, we do student myself equals to a new student. This here, this is calling the constructor of student. Now in Java, your constructors are default, and that means that if you don't define an explicit constructor, something that's specific and adds like more code onto the default, then you just have a completely empty constructor that's a default. And I can show you what an empty constructor looks like. So essentially, I just share my screen and then ignore this stuff. We'll get to that in a sec. Okay, essentially you go down here and you say we have a class called let's just call it student. So student. And then let's say we have one field called name. So we have a name for the student, and then we don't define any constructors, but we can still make it up here. So if you see student myself goes to a new student. So you see that up here, we can still make one even though we didn't define a public student constructor. Essentially what this is calling up here is what I'm about to write. So you have public students, and then you don't put anything in the parentheses because there's no parameters being passed in here. And then down here, you say, oh, nothing, because this is default. So this would be a default constructor. And then if you actually wanted to add something to it, we could say public student, and then we could say, oh, grade level, and then it would be this dot grade is equal to the grade. So yeah, there you go. That's how you, oh, I had it set as string, but yeah, there you go. That's what you do. And this just goes to show that you can have a default constructor, even if you don't define it explicitly yourself, you can still have one. And then if we go up here, what's interesting is that you can see that we can actually create another student with both of these constructors here. So we can either use the default one or we can use the one that gives it a grade. So maybe we don't know the student's grade. Maybe I forgot my age. So I don't know my grade. I just made myself an empty student. I don't have a name. I don't have a grade. But if I did know, say, my sister's grade for some reason, sister, then it would be sister student. Let's say she's a junior. There we go. That works. And then you can run this without any errors because we have both constructors in here. So that's pretty cool. Constructors are super useful because you need to call them whenever you're actually creating a class. Okay. So that's great. Moving on. Okay, we've done this already. Constructor, blah, blah. Okay. So one last thing, I think. What is the meaning of static? Does anybody know what the definition is of that? And what makes static different from not having static? If anyone actually remembers what static means. Any ideas? No? It's okay. Basically, static simply means that the variable or method can be used without an object. So what does that mean? It basically means that essentially you have a class, and normally you would have to create an object to use the behaviors of that, because a class you can imagine is something that's imaginary or theoretical, but then if you have an object of that class, it's something that becomes physical. So say we had a template for a pencil. Now, normally if it's a blueprint or like however they make these, a stencil, I have no clue. Essentially, you have to actually make the pencil to do anything with it. But then when you have static and when you use static, that means that the blueprint itself has properties that you can use. So that would look like, I can demonstrate here. So that would look like a static class, say, static. Let's say all students go to the same school. So static string school. And let's say that's equal to, I don't know. I don't know what BPPS is. Essentially, either way, we can just say, so because it's a static, you see that we don't have to actually create an object. In fact, we can't use an object for this. We have to use the blueprint, the class itself. It has to be student.school, and then this will give us the school's name. So you see here, what's printed, it says Great High School. Nice. And then if we were to try this with an object, so let's say myself, let's see what my school I go to. The static field student.school should be accessed in a static way. And then let's try to run this, and I'm pretty sure it gives you an issue. Oh, it doesn't. Oh, I guess it's because either way you can just access it from an object because it's within the class. But yeah, student basically adds the functionality of you being able to use it without creating an object. So we could just delete both of these and just use it with student itself. And that's super helpful for many things. This morning I had to use it for a program. I was trying to sort all of these numbers, I think, cows, I forgot. But I was trying to sort all of these things and I had to use a static comparator, static method to do it. So static is super helpful. Okay, I think this is the last slide for review. How would we actually print the method called print region? So you see here, we have a string species. It's empty. I guess the animal doesn't have a species. And then we have a region called Africa. Oh, I guess species is getting assigned down here. So when you create the animal, you have to give it a species. So you pass in a string species gets set to this whatever species you passed in. And then down here, get region. How would we actually call that? Well, I guess it's not print region, it's get region. But how do we call that? Any ideas? No? Okay, well, either way, you call it by going inside of main and you essentially say, oh, let's do the animal because it's a class, it's a static method. I forgot about that. And then you do dot method name, and that's essentially how you call it. And if we saw earlier that we had a static variable, but of course you can have static methods too, and that just means that you can call the method without actually having an object like we had previously. And one last thing about constructors, I forgot to mention this earlier, but if your empty default constructor is not here and you have a constructor defined, see, after I deleted that empty constructor, now we just have the constructor that says, oh, give it a grade, and then you have to give it a grade. So essentially, the default one that's empty is gone now, and you can't use it. So if I say myself, if I somehow don't remember my grade, then you wouldn't be able to make a student. See, this gives us an issue because you have to have a student constructor where you give it an int value. So let's say this is 10th grade. There you go, that works. So yeah, that's pretty basic. And then I think we're done for reviewing the OOP concepts from last week. We can move on now, hopefully. Actually, before I move on, are there any questions? Because what we covered last week and I guess review just now is kind of heavy. Questions? No? Okay, I'll assume that's a no, and then I'll just move on. Okay, so last session, today's the last session, and here's basically what we'll be doing, going over the schedule. We'll be doing encapsulation, inheritance, and Arraylist. So you might have heard of some of these, probably sound familiar. Encapsulation sounds like a cool word. Arraylist, you might have, part of this word probably seems familiar to you, the word array. And then inheritance, it's not just someone giving you money. It is another concept in Java. So let's see what these are. First of all is encapsulation. And encapsulation is just when you create a company. Okay, well, this is an example, but when you make a company, you wouldn't just want anybody to look at your private financial information, like your company logins, your tax records. What if they expose you for, evading taxes, and then you have to escape to another European country? Essentially, it's very dangerous. So when you want to keep those things private, you want to use encapsulation. And what that means is that you're using methods to protect private information. This word's important, private information, the keyword private. And then it's useful because it only makes them visible within the same class. So you can't just go at it from another class. For example, if I had a cow, perhaps only the cow knows how long it slept, or only the cow knows how much it weighs, so that other people can't just go and get that information. So that's pretty abstract though. So I don't think you understand what that means. So I'll just show like a more practical example of this. Actually, before we get to that, my bad. We need to go over public and private. So public and private, if you want to do anything practical with encapsulation, you need to use the public and private. That's the main concept of encapsulation. So what does this actually mean? Public and private are access modifiers, as you see here. They control how you access the variable and method. And that makes sense, right? If you have something that's private, the only thing that's restrictive about that is how you access it. Private information is private because you can't easily access it. So public is the opposite of private. It can be accessed by all classes. And private just means that it can only be accessed by the class that it's declared in. So that might seem pretty weird. Like, what's the point of having all this information instead of a class when we can't even look inside of the class and get it? What's the point of having like a blueprint for a pen when we can't see how long the pen is? Except only the pen knows, and that doesn't make any sense, right? The pen doesn't have a brain. So this doesn't make any sense. And that's where getters and setters come in. And we'll get to that in just a second, actually. So let me just demonstrate what would a private variable look like. So essentially we've been sticking to just the type for the most of this past week. So we've just had string, name, variable name, and then we had like the type int, and then we had the variable name grade. That's not terribly useful though, because 99% of the time when you're coding, when you're actually doing like a program, you want to tell it if it's public or private. So we can say public name, and then actually let's just say private grade, and then public name, because everybody knows your name, right? So okay, and now we see here we can make ourselves a new student object called myself. We give it the grade 10th grade, and then we can also give it a name. So let's make sure that we can give it a name. Let's say Yanda, that's my name. And then we would also have to add it to the constructor, of course. So this dot name is equal to name. So yeah, that looks good. And then we can essentially demonstrate the concept of private by going like this. So we have a print statement, our system.out.println, our print statement. And then we can say student dot, let's say myself dot name. Now let's try that. This should work. There shouldn't be any issues with it. There you go. That's my name. And the reason this worked is because it's a public. With public, anything, all of this, anything can see it. But with a private, we've said that only a class can see it. So this is what it looks like. We have myself. I want to see what grade I'm in. So let's see, is in name dot grade, myself dot grade. Oh no, it's giving us an issue. It's giving us an error because we can tell by the red underline here. Well, why is it giving us an issue? So the field student.grade is not visible. Now, when you see this, what it means essentially is that you actually can't see inside of myself and look at the grade because it's private. Now, if we were to change this to public or even just delete it, the error would disappear. So look, now we can do it. And same with public. So public, like I said, just means that everything can see it, but private means that only your class in here can see it. So that's why we can do this dot grade and all of that. It makes sense because it's kind of its own entity and you can't see it from outside. Okay. So how would we actually access these private variables? If we had my name be private, how would we go about getting my grade from outside the class? And that's where getters and setters come in, like I said. So getters and setters are pretty crucial to Java. They're pretty basic concept, and this is what they look like. Okay, so getters and setters. So you basically get methods basically return the variable so that you can get it from outside the class, and setters set the variable. So both conventionally with syntax, you want both of these methods to start with get name or set name, or get age and set age. So that's what it looks like. If you had a cat named Ponyo and then you wanted the age to be 5, you could say get name and then you would return the name, or you could say get age and you would return the age. So we can demonstrate this. Let's change this to cat because I like cats. Okay, so you have that, and then we can delete this. You can see that there's an error now because the constructor's name is different from the class's name, so cat was different. But let's just delete this, we don't need it. And then we can demonstrate to ourselves how to use these getters and setters. Now, very important is that your getters and setters are public, because you want to be able to see them from anywhere, and you want to be able to get these variables if they're private already. So let's say private for both of these. So you wouldn't want your getters and setters to be public so that anyone can use them. And then you also want your setters to have a return type that corresponds to what you're trying to get. So essentially, we can't say, oh, int get name, and then you wouldn't need parameters. We can't do this. So you see that it gives us an error when we try to return the name. Even though we're trying to get the name, we have int as a return type, so that we can't actually return a value of the type integer from this method. So we would have to change this to string, because we know that the name is going to be a string. So now we can do public string get name, and then returns the name. And we can just do the same thing with everything else. It's pretty simple. Okay, nice. So now we can say, oh, let's create a new cat. Ooh, we adopted a new cat. So cat, we'll name it Ponyo because that's the name. New cat. And then we can say Ponyo.name. This doesn't work because it's private, but then you switch it to get name, and now you have the name. Now this turns into a string. And then we can say Ponyo.get age, and this should work. So let's say yay, Ponyo's 5 years old. That's nice. So you see how that works. Okay. Actually, before I move on, I realized that I forgot to demonstrate setters. So, and they're not in this PowerPoint either, somehow. I guess I kind of just forgot, but setters are basically the same thing, except the big difference, and this is something important to keep in mind, is that your setters need to have a void return type. So what does that mean? It essentially just means that you have void here. So because it doesn't give you back anything, all you're doing is setting it. And then you say set name. If you wanted to change your cat's name, I don't know why you would, but you might want to. And then you want to say string, we can call it a new name. Notice that with getters, you don't have anything for the you don't have anything for parameters, so you don't need to give the method anything. But then when you're setting it, you need to give a value to the method so that it can set it to that value. So we can say name is now equal to new name. Okay, so let's now. Let's do this print statement twice, and then, but before we print out the second time, we can say Ponyo dot set name. Let's change it to Nico. So Nico is this new name, and then let's see what happens. Boom, there you go. Ponyo is 5 years old. Nico is 5 years old. That's what happens when you, and we actually did change the value of name itself. Even though it's private, we were able to do it because we used a set method. And we could do the same thing with age, but I won't. So yeah, there you go. That's your setters and getters. And now let's just do an exercise. So create a new class called friend and have the fields name, age, favorite animal, and color. And I want you to make a getter and setter for favorite animal and color, but only use a getter for name. And age should have a special setter where you can only increase it by 1 at a time. So I guess it's not really setting anything, it's adding 1 to the age every time you call it. Try to be creative with this, make it as if you're actually interacting with your friend, and then I'll show how to do this at the end. So Hopefully we've gotten somewhere. I'll start going over it in a second. Okay, I'll just go over it now. And I don't actually have it created, even though I did ask you guys to create a lot of the fields, so I won't do all of them. But let's just say we have a class called friend. And then name age for it. So name, age, and then it's favorite animal and color. So favorite animal. And color. So yeah, there you go. And then you have your, I think all this private to actually practice using getters and setters. And I'll just do two of the setters. I'll do the name one and then also the age one. Actually, I'll do the animal one and then also do the age one. So and a cool thing about getters and setters is that in some IDEs, I think IntelliJ, I think they actually automatically create them for you, so you don't need to go through all this pain of typing it out yourself. But I don't mind it too much because you do kind of get to control more closely like what you're actually doing with the variables. And then another thing is that don't forget to make the special setter method, which is just a void, but you instead of doing set age, I guess we can still call it set age, but then because you don't really get older by 5 years at a time unless you're traveling through space or like space and time, I don't know. You wouldn't want to just do like age equals to some kind of parameter. You want age to be increasing by 1 each time. So this is still in a way a setter because you're changing the value that's private and this is how you're changing it. So we can test this out now. Let's just say public, let's say the name, let's make the constructor have a name. Usually you would want to initialize all of these variables in the constructor, but we won't be doing that today because I'm lazy. And then we can just do age, this dot age equals to age. So that works. And then this dot name equals to name. Okay, so let's go up here and test that. So we can say goodbye, Ponyo. I'll talk to you later. We'll say friend, let's call a friend Jack. Actually, I have a friend called Jack, but we'll give its name as Jack, and then we'll tell him that his age is 14. And then we can print it out. Let's see, system dot. So Jack dot get, oh, we didn't do a get name. That's a big oopsie here. Get name, and then we can say return name. And then we can also do a get age because we're going to need it. And so we can do get age, and then we just return the age. Okay, so up here we can do jack.get name, and then we can also do is we can do jack.get age. Okay, so hopefully this makes sense, and then let's test this out. But I want to actually also do something else with it. Okay, nice, Jack's 14. But what makes this cool is that because we're incrementing, we can basically just say, well, while the it would be super cool if we can say while Jack get age is less than, let's say, 18, we do okay, so this should work. Like I said, I want to make this slightly more interesting, interacting a little bit, and then we can do jack.get age. Okay, so if we did this right now, if we just went ahead and pressed the button, we would get an infinite loop. And I don't like infinite loops. I don't know about you, but I personally aren't the most fun of them. So let's just do a set age. To be honest, set age isn't the best name because you're only adding by 1 each time, but we'll just call it set age for now. And let's see what happens here. Hopefully this works. Nice, it does. So as you can see, our while loop proves to us that our set does work. It says Jack, you are underage Jack, you are 14, you're 15, you're 16, you're 17. And the reason it's increasing is because we're doing set age each time here, and it's going up each time by 1. So that's a cool way where you could implement while loops and classes. You won't be doing that too often, though, something this simple, but yeah. Okay, moving on. So why should you actually use getters and setters? It's pretty important to know why you're doing this. So getters and setters, they allow for read-only or write-only fields. And what that means is that sometimes you want to only be able to change something, you won't get it back. That's not that common, but a lot more common is a situation where you want to get something, but you can't change it. So essentially, you could say, oh, I want to get this company's name. Let's do company.get name or company.get public report. But they don't want you to change that because it's their company's private details. So basically, you don't have access to a set method, but you do have access to a get one with a read only. And that just ties back once again to security of data. In a lot of actual programs that are big, multiple files, multiple classes, hundreds of objects, you're going to have instances where you might not want the other person in another class to be able to see your data. So it's security of data. And then another very important thing is that because of these getters and setters, we can change one part of the code without actually affecting another part. So let's look here. Let's look back here. If we wanted to change the way that we set the age, we wouldn't have to change anything else except the code that's inside of set age. If let's say age is getting added onto by 2 each time. So this should be good. And then let's see what that gives us. Jack, you are 14, you are 16. Jack's a time traveler. He wasn't here for 15 and 17. Apparently, he skipped right to 14, 16, 18. So that just shows you that it's a very good way to kind of cluster your code in such a way that you don't actually have to change everything at the same time. If you just wanted to change one part. 12 Eastern time and 9 Pacific time is the same, I believe. It's 12 Eastern time, essentially. Okay. So last thing is that your code having your getters and setters simply means that you have better practice and organization. It's because if you actually wanted to see robotics code, which is something that I've spent a lot of time on, is coding for a robotics competition, then you need to use a lot of getters and setters and basically just organize it in such a way that you actually know where you're getting these motors from, where you're getting these power values, these controllers, all this feedback stuff. All of it is based on getters and setters. There's almost no just straight up getting like a variable unless you wrote the code yourself and you just want to get it. If you're using someone else's code, if you're using the code that the university gives you so that you can actually run this bot, you're always using a getter and a setter. You're not ever using anything else. So that's just a pretty cool concept. Getters and setters are super useful. Okay, well, next thing. This is a big part of Java and OOP. So it's Java inheritance. And what does that mean? Has anybody heard of inheritance? Does anybody know what it might mean? No ideas? Okay, inheritance is basically a concept where you can inherit attributes and methods from another class. So what does that mean? Well, essentially you have a parent, a child first, a subclass, which is the class that inherits from another class. And then you have your superclass, your parent, the class that is inherited from, the class that you get all these attributes and this behavior from. It's like they say, the apple never falls far from the tree. So your parents do influence who you are, obviously. That applies in real life too. And essentially that just means that you're inheriting certain traits from your parents. If your parents had blue eyes, if both your parents have blue eyes, then you have blue eyes, that you're inheriting that. Actually, I don't think that's true. I think it's like the way genes work. I don't think that's true at all. But I think it's true if both your parents have brown eyes. If both your parents have brown eyes, I'm pretty sure that no matter what, you're gonna have brown eyes. So that's just the way that in real life, genetic inheritance works. And then with coding, a similar concept applies. Basically, it's basically the same. If you have a string field called blue eyes or called eye color, and you had it blue for the parent, and then you make a child class, and you don't change the variable, it's still going to be blue. So that's pretty cool. And that's just how like an inheritance works. And here's how you do it. You want to use the extends keyword, and then you want to have one class, obviously, that defines some behavior in some fields, and then the child class will inherit these behaviors and fields. So you can test this out. As you see here, we have a class called animal. That's the parent class, and then we have our method within it called yell. So basically, animals yelling something. I'm not sure animals make this noise. And then you have your child class called cat that extends the animal, and cat has a string called species, because not all animals are cats, but all cats are animals. It's kind of like that. Okay, so demonstration. What was I going to demonstrate? I don't quite remember, but actually no, I do remember. Let's call this animal.java. New file. Animal.java. We'll say that there's a public void make noise. And let's just have the animal scream out of happiness. There you go. Animal is screaming now. Then we have cat. There's a species. So string species is equal to cat. What else would it be equal to? My bad. Oh, important thing. We forgot to say that extends. So extends animal. So there you go. And then we actually don't have to do much else, except we can say up here, I kind of don't like how this is set up. So because it's a little confusing for someone who might not understand it, but it's fine. We'll just have the main up here. And then we can do, let's make the cat scream. Don't make cats scream in real life. I don't know why they would. So the fact that you have it screaming is not a good thing. So let's say Ponyo equals to new cat. And then let's just say Ponyo dot make some noise, make noise. So what's super interesting about here is that, let's test it out. Boom, you have your cat yelling ah. And what's super interesting here is that despite us saying that it's a cat and its name is Ponyo, and cat, it's empty. It only has species, but it still can make some noise. And the reason that it does that is because it extends animal, extends. You can think about it like if your parents are one unit and you're the child, you're extending them the next generation down, I guess, something like that. And essentially, this is super interesting because you can have multiple classes extending this one big parent class. You can have a lot of default methods and attributes. And essentially, that's what parent classes are for. You want to have parent classes that can define something once, and then you want to be able to reuse that code. So going back to our PowerPoint, oh, kind of skip past it. I guess I'll keep talking about inheritance a little bit more. So another interesting thing is that, let me just demonstrate how you can have how parent and child relationships work in Java. So let's say we have public void meow. So let's say the cat meows. System print line, let's say it's a meow. Okay, there you go. The cat's meowing. Now, this is cool and everything, and we can test this out, but this is super cool concept about this. So meow, and then let's just show you what that does first. Okay, boom, it screams. Well, it shouts, not screams, I don't know. And then it meows. Okay, so we saw how the cat can scream, can shout. But now if we say animal, my pet equals to new animal. So it's an animal object. It's from up here, from this class. Now our issue is we cannot say my pet dot meow. We can say my pet dot make noise. So when we run this, it says can't find symbol. It actually can't find whatever this method is supposed to be. It says dot meow, and the cat has no idea what that is. I mean, the animal has no idea what that is because animals typically don't meow, right? Only the big tiger, only the big cat, feline animals can. So that's super interesting. You see how the child class can do everything the parent can, but I guess the parent can't do what the child can. I guess it goes in real life too. Sometimes you're, improved upon your parents. Maybe you haven't, but okay, moving on. If you don't ever want your class to be inherited, just use the final keyword. It's pretty simple. And the final also has a couple other uses with variables within a class. And this is useful for organization, and it also prevents accidentally changing a variable. So I'll show you what that means. Okay. If we have, it's pretty simple. If we just say public final class, boom, now we get a big issue. It says the type cat cannot subclass the final class animal. That basically just means that animal is not having any children. It has no kids, has nothing that extends it. If we have final up here, we cannot extend it. And we delete that, and now it's fine. Another interesting application is if we were to say, let's say this. Let's say this says meow. Okay, let's put this out. Let's see if it works. I have to delete all this first because the animal can't meow. And then if we do this, it says the cat says meow. This cat says meow. That's good. Okay. But now if we make this final, then we have an issue because, oh, we don't actually have an issue. My bad. I was thinking about something else, but okay. To demonstrate that, I guess I'll just do this. So if we forget everything I just said, sorry. If we had a setter set species, you can't really change an animal species, but we'll try it and then it'll give us an error issue. So if we do species equals to new species. Look, now it gives us an error. So basically it's telling us the final field cat.species cannot be changed, cannot be assigned. And that's what this is. You can see how it changes colors too. Actually, it's pretty cool. If you delete this, it goes back to like pale blue, but this just shows you that it's a final. And essentially it just means that you can't ever change it, even if it's in its own class. You can't change it in the code. And this prevents yourself from accidentally changing it or from someone else trying to change it. So for example, if we had public final string species, and then we said up in here, ponyo.species equals to dog. This would not work. You cannot change what species is. And that's just another way of letting you see the variable but not actually change it. And this is pretty obviously useful because you don't just want people to change the species of your cat. If you fall asleep with the cat, you wake up with a cat, not a dog. So it's pretty useful in my opinion, at least. Okay. Moving on. So why is inheritance useful? I guess I should have put this inside of the final slide. But inheritance, essentially, like I said, lets us reuse code, and it gives us the option to add more specific functionality to what could have been a broad program. So like we saw earlier, the parent, let's say your parent only knows how to play soccer. So essentially you could, if your parent was, say, like Messi, then when you were born, you would be born with certain methods, certain attributes, certain things that are passed down, inherited to you that you wouldn't want to change or you wouldn't change. And then, but you could also say you had a passion for basketball. You could learn how to play basketball by adding another behavior, another method onto the child class. You're the child class. We can add another behavior to you that lets you play basketball instead of just inheriting Messi's soccer skills, which I don't know why you would want to play basketball if you're as good as Messi, but yeah. Other than that, let's move on. So polymorphism. This is also another very important concept within Java. So does anybody know what poly means? Any ideas? Poly? No? Yes? Yeah, good. It's many. It means many. I think it's like a Latin or Greek stem word. I have no clue actually. Yeah, it means a lot. It means many. And polymorphism, polymorph, changing shape. Ism is like, its trait. Polymorphism just means it can change to many different things. And it essentially means that it's many different ways to implement the same behavior. So I'll try not to move into commit, but essentially, if you look here at this code snippet, this screenshot, you see the species dog, and you see pig extending animal, and you see dog extends animal. So we have a species pig and we have a species dog, and then we say animal sound, and it prints out two different things. And what's interesting here is that we have actually two different ways, two different code blocks inside of this method, even though they have the same method name. And as we learned earlier, it extends the same parent. But this is the reason why that is. If we look here, I think it's here. Is it? It is here. Look at this. We have down here, pigs and dogs are not necessarily the same. It's just like how you might have the same parents as your siblings, but you don't have the exact same traits as them. You don't play the same sports. You're not the same height. This is what polymorphism is. It simply means that once the child inherits things from the parent, it can change those things. So despite animal having a definition for animal sound up here, it says animal has already defined what animal sound means. It means, oh, the animal makes some sound. But then down here, when we actually do polymorphism and we implement new methods, we can change what that means. We can change what it does. So if you see here, now pig says oink. I mean, pig says we. I don't know why pigs say we. Pigs don't say we, but whatever. Pigs say that, and then dogs say bow wow, I guess. I've never heard to say dogs say bow wow either. So There you go. Very inaccurate animal noises, but they're different from each other, and that's what polymorphism is. It's differences between siblings. And we can run this code actually. It's pretty simple. It's pretty interesting. And when we run it, I want to point one last thing out to you. So when we run the code, it says the pig makes a noise, we read, the dog makes a noise, wow, wow. And then the we made a new cat. So we have a new animal, my cat. It is called new cat. It's a cat object. And then it says animal sound, but it doesn't make a new sound. It just says the animal makes a sound. And it's like we said earlier, the cat actually hasn't defined any new animal sounds. That means that the cat isn't exhibiting any polymorphism. It's not changing anything because its make sound method is the default one. Its make sound methods up here. It just makes a noise, makes a sound. So that's pretty cool. And then one last thing that I want you to notice, to take note of, is that up here we have up here it says animal, and then my pig equals to new pig, and animal my dog equals to new dog. So it doesn't say just like dog and my dog equals to new dog. And the reason that we can have animal in here in the front is because a dog is a subclass, a child class of animal. However, an animal isn't a child class of dog, because not all dogs, I mean, not all animals are dogs, right? But all dogs are animals. So this is why this works. So animal, my thing equals to new dog. That's why this works. But if we wanted to change it, if we said dog, my animal, dog, animal, look, there's an issue now because you can't convert from an animal into a dog, but you can convert from a dog into an animal because a dog is already an animal. So that's like a pretty like common sense thing, but you do have to realize that and remember to keep track of that. And this actually is pretty useful too, because a lot of the times that you don't want to define which child class that you're setting up a new object for. So sometimes you want to leave it open so that you can change it later on. So that's why it's pretty useful to have this, set it to your parent class first. So yeah, basically calling the animal sound method for different objects give different results. It's pretty simple. Okay, more on polymorphism. It's useful because it allows specific behavior while you're reusing your code, so that there are attributes or behaviors that we might want to keep. And we can keep them because we just changed specific behavior. We just changed the noise the animal makes. We didn't change how, we didn't change if it had, let's say, skin or not, or had a vertebrae. Maybe that's one of the traits. So yeah, we didn't change any of that. We just changed whether or not it made a certain noise. Okay, so here's an exercise. Apply the principles of polymorphism. Now, step one is going to be implement a vehicle superclass that has a method for making a noise and a field for gas tank content. So basically, just make a vehicle superclass, and there's a method for making a noise. Maybe it's like tut tut tut. It's like boom. I don't know. And then there's a field. There's a variable for the level of gas that you have. And this is just step one. So I'll check back in about 5 minutes. Okay, I'm back. So it took me a while to actually get a cup of water, and then I'll go over the step one in just a second. Okay, so step one, make a vehicle superclass, right? So, oops, just delete all this. We don't really need it. So vehicle, and then we have to make two fields. I mean, one field that's uh, private int, fuel in gallons, and then we have that set to 0 for now, and then we can do a method make noise, and all that does is basically just print out a noise. There you go. Very pleasant. Okay, so step two. I'll give about 2 or 3 more minutes for this, and then I'll go over it again. Basically, just create a new child class called car that extends the vehicle superclass, and then have the car use polymorphism to make a different noise. And I'll paste the vehicle code in here. Okay, so try that out, and then I'll give a couple more minutes, and then I'll come back. But I hope that's enough time. I'll go over it now. Essentially, so when we're creating a child class called car, basically just have it extend, and then we can have it use polymorphism to make a different noise. And that's pretty simple. You just need to find the method again. So class car extends vehicle, and then we say, we just have to define it again. So this, we can even do something in Java called override. So that kind of marks it out as overriding it, and then we say make noise. Then we do system.out.println. The code would make a different noise, right? Let's say like, yeah, woo. Okay, so that's pretty simple. And then the last part is probably the most important one because you actually need to finish this off, right? So we have to create another child class called plain, add some cool stuff to it, and then test in the main. So I'll give 2 more minutes for that, and I'll put this piece of code in the chat too. I'll give about 2 more minutes, and then I'll finish this off. So yeah. Okay, I hope that was enough time. Okay, I'm just gonna go over it now and then implement the plain child class and try to test it out. And yeah, oops, that is not what we're trying to see. Okay, so let's have another class called plain. Let's say it extends the vehicle to, and then we can have it make different noises, right? So we can say add override the old one. We can say public void, and then make noise. This one we can put as what noise does a plane make? There you go. So that's pretty accurate. It's the noise a plane makes. And then we can say we can make a new constructor for this too. So let's do that. Let's say, because whenever we want the plane to get off the ground, we want it to have at least this much fuel. So we'll say plane into fuel level. And then we say if fuel level is less than minimum. And then how I'll make this more interesting is by actually defining a minimum for this. So we can say static, because all planes have, let's say they all have the same amount of minimum gallons that it needs to get off the ground. And then final, so we can't change this unless we have a new plane design. So we'll have a static final. We can't change this. It's the same for all planes. Int minimum fuel. So that's what it'll be. And then actually, let's just set this to 10. So if it's less than 10, you'll see what happens. So static final int minimum. In robotics, usually this is like the port number or something, because you won't be changing that. And then if it's less than the minimum fuel, then we say plane is not ready to get off the ground. Then if it's more than that or at that level, then we can, but for this part, let's just set the actual fuel in this dot fuel in gallons. Does that not work? Oh, I'm not allowed to access that. Okay, wait, here. This is what you do. This is a pretty complex part of it, but let's just do this. So we have to make a constructor for the vehicle. We have to say fuel in gallons. Fuel, and then down here we have to. This part's kind of weird. Just don't worry about it for now, I guess. If you want to do more research into it, I'll send out a follow-up with readings and all of that. But we can basically just say fuel, and then that should work. Oh. Interesting. Okay, wait. I haven't done this in a while, but essentially you just say fuel zeal, and then else you say oh, I just forgot that you can't edit the supers variable unless you actually make your own. So I guess you could just like say down here like private and fuel in gallons, and then there you go. That should work. And now you can say fuel in gallons equals to fuel level. Okay. And it's a little disappointing though, but then you can down here you can say fuel in gallons. And then you can test this out pretty easily. You can just go up here and you can go up here and test. So, and you can just be like vehicle Boeing plane equals to new plane. And we can say 15, and then that should be ready to fly. Then we can say vehicle equals to new car. And then we can say car dot make noise, and then the Boeing plane make noise. So yeah, there you go. That's pretty simple. And then test this out. I guess we're not really using the fuel functionality that much. So look, there's your make noise. And then, but up here, if you wanted to change this to 5 and actually like get to see what happens with the custom constructor, down here it should say, oh no, planes are not ready to get off the ground. So yeah. Inheritance and classes can get pretty complex pretty fast, because you have to be coordinating and interacting between all these different files, all these different classes, and all of that. But it's super useful. You have to use it a lot when you're actually doing practical programs. Okay, last thing for today, last thing for this course, I guess. My favorite thing in the world, Arraylist. They're not my favorite actually, but they're definitely up there because I use them so much when I first started coding because they're super easy to use in that they're resizable. So when you get lazy, you can just make it bigger. When you get lazy, you essentially just add to it. You can just add, you don't have to worry about the size at all. And it's super easy to get things from it. It's super easy to traverse through it. So yeah, Arraylist is it's very easy to use and versatile, and it's slightly different syntax from a normal array. And it's basically the same as an array, except like I said, it's you can resizable. You can change the size, and it's from the java.util library. So I'll show what that looks like. Okay, so here's an example of it. You have your array list type E. You have the name of it, name of array list, new. Don't forget the new keyword and a new array list. Array list is obviously its own class, so you're making an object basically. And here, down here, you see array list string cars is equal to new array list string. So you have cars.add, and then this is how you're adding to the end of it. And essentially what this means is that you're adding elements. You have to, when you do array list dot add, you're adding it to the end. You're appending it onto the end of the array. So you're not inserting it into the middle, but there is an insert function. And here I'll show you what it looks like. If I can find it. If I can find it, where is it? Oh, there it is. Let me delete those friend stuff. We don't need friends. Up here, there we go. Yay. Okay. So this is the code that we had for the list. And after adding all of these elements to it, you can see down here we have Volvo, BMW, Ford, Mazda. And what's cool about Arraylist, something I actually like decently about them, is that you can just print them out. You don't have to traverse it yourself. You don't have to go through it yourself. It's relatively simple to do. So that's how you do it. And yeah. And also don't forget, one important feature of these is that you have to have the type of what you're going to store. So usually if you have a string array, you would do string and then brackets, right? It would be like cars array, and then it would be like new string, and then size, whatever you want the size to be. But with array lists, only thing you actually want to do is put the string inside of these like sideways carets. I don't know what you call these. Oh, wait, my bad. They're the greater than or equal to sign. They're greater than or equal to signs. But yeah, so you put them inside of that, and then they have to match on both sides because you're saying that, oh, I'm making one of type ArrayList string, and then, but you make the object itself has to match it to be stored within it. So that's pretty cool. And if you see here that if you try to add, say like 20, 12, it's not gonna work. It's not a string. It's not a string, so it's gonna say the method add in string is not applicable. And then what's actually pretty cool about the add function, like you saw just now, we can actually insert. So we can say one. We can add it into the space at one. We can add all these to one, see which one actually ends up at one. And it's the last one that gets added there. So it's going to be the Mazda. Well, so it goes. So before we had Volvo, BMW, Ford, Mazda. Now it's Volvo, Mazda, Ford, BMW. And you see that because all of them gets inserted into the position at one, everything that's at one or after it gets pushed back one. So now Ford and Mazda push back one. So that's just how that works. It's pretty cool. There's a lot of ArrayList like functions, a lot of functionality that comes along with it. I highly suggest exploring this. It's called data types in Java. I'll send out a link later so you can do some exploring yourself if you like it. So yeah, it's really nice. Okay, one last exercise for this course. Try to create an array list of every single even number from 1 to 100 and then just print it out in order. Please use a loop. Don't do it by hand. Okay. I hope that was enough time, but I want you guys to get some sleep, and also I'm tired too because I had to take a mock SAT today. But okay, let's just do it. So array list, let's say string, let's make an integer type, and then it'll be, let's call it 1 to 100. Ooh, yeah. And then we say, and then here, let's use a loop, right? Because I don't want to do this by hand. That would be a pain. Int I equals to 1. I is less than 100. There's definitely smarter ways to do it. Like I could increment it by 2 each time, but we can just also use an if statement. If I mod 2 equals to 0, 1 to 100 dot add I. There you go. Pretty simple. Huh. Oh, it's an and instead of a mod. There you go. Every single even number from 1 to 100. There should be 50 of them. Nice. Okay. I think we're done. I think we're done. So yeah, thank you guys for being here for the past couple weeks, 8 weeks, I think. That's the end of Introduction to Java. I'll send out all the slides. Maybe I'll actually update the Google Classroom for once, and then I'll send out some readings. To be honest, I highly suggest exploring coding on your own and Java on your own, because I get the feeling that you're not going to remember everything you learned from this, and that's perfectly fine. So yeah. Will this class be in fall? I don't know. If I want volunteer hours at that time, if I have time to do it, more likely, because school is going to get busy next year. But yeah, that's it for this course. Have fun doing something, guys. Definitely learn how to code. Don't waste time. And yeah, bye bye. You guys are free to go.